Thank you so much for taking your time for my session. It's about TensorFlow Lite. I'm Kaz. I have been working at Google for over 7 years. It's almost 8 years now. And for the last 6 years, I have been working at Google Cloud team, Google Cloud Platform as a developer advocate. So it's a role just like the evangelist. So I usually attending the public events like this or meetups, talking about the technologies. Especially, I'm focusing on the machine learning and data processing technologies right now. So today, I'd like to discuss about these topics. Why ML matters for you, especially for the mobile device or the embedded devices. And what is TensorFlow? TensorFlow is the open source framework developed by Google to build your own machine learning and deep learning model from scratch. And what is TensorFlow Lite? TensorFlow Lite is the lightweight version of TensorFlow runtime that will be running on the mobile device and embedded systems. And how you can write your own program code to use TensorFlow Lite. And lastly, I'd like to show many interesting videos and demos using TensorFlow Lite. So why machine learning matters for you, for mobile developers or embedded systems developers? This is the usual slide I use to introduce what is the meaning of the AI or ML or neural network. There's no scientific definition of what is AI. So many vendors or people are talking about the different interpretation of the AI. But Google think it's a science of making things smart. We're trying to make the IT systems much better. Rather than building, simulating the human brains by emulating the neurons, it's called strong AI, and Google is not looking for that. We are looking for so-called weak AI that could make the IT a little bit smarter. And there has been many different approaches to realize the vision of the AI. One of them is machine learning. What is machine learning? So usually, in 99% of the existing IT systems, you have to hire the programmers to instruct every steps for computer to solve the problems. So computers would read all the instructions, softwares, to handle the data processing. So that's how we are building the IT systems right now. But with machine learning, you don't program the computer. Instead, we use data to program the computer so that we let computers leading all the data, training data, to extract certain patterns or statistics, the characteristics from the data. And there has been many different algorithms and ways to implement the machine learning. One of them is neural network. And there are many other algorithms, such as the random forest or SVM. But at around 2012, some researchers have found there's a tremendous opportunity or the tremendous possibility when you are building the large-scale neural network, so-called deep neural network or deep learning, with the tons of data, big data, and bunch of the computing resources by using the GPU. And as I said, the AI Google is trying to make the IT a little bit smarter, not aiming for replacing the human brain. So although it's called AI or artificial intelligence, I always say that there's no intelligence in AI, in current weak AI. It's just a function in the programming language or function in mathematics. So you can have a function that can take any kind of data, such as the image data or sound data, or the business data you have stored on your databases, MySQL or Oracle. And you can train the function to get the expected result from data. For example, if you have a bunch of the images, like a cat images or dog images, you can try training the neural networks to get the result as cat or dog. So all the neural network is doing inside it is just a transformation or conversion of the data. There's no intelligence or consciousness in the neural network. But if you have more and more layers in a hierarchical way, that is so-called deep neural network or deep learning, then very interesting thing can be happening inside the deep neural network. For example, this blue diagram is the design of the Inception version 3. That is the image recognition neural network designed by Google. And if you put the image data from here, and it would output the labels such as a cat or dog or a forest or flower. If you take a look at what's happening inside those neural network layers, very interesting thing is happening. For example, in the lower layers, the neurons are trained to recognize the edges or patterns of the objects and images. And neurons in the middle layer can recognize the animal's eyes or nose. The neurons in the higher layer can get much, much smarter to recognize there's a dog's snout or cat leg. And eventually, there are neurons that can recognize there's a Labrador retriever or tiger cat. So at around 2012, some researchers have found you can train this kind of very deep neural network to get the high accuracy on the image recognition and many other AI tasks. And Google has been using this technology for realizing many of our production projects and production services, including Google Search and Android Maps and other over 100 or 200 production projects. And we have been traditionally using the machine learning for many years from the start for the services like AdWords or Google Search, but those has been traditional machine learning algorithms. At around 2013 or 14, the use of the deep learning inside Google has been exploding. For example, Google Search Service has introduced deep learning-based ranking algorithms since 2015. So if you're using Google Search right now, then the ranks you would see on the search result, that is defined by the deep learning algorithms. And another apparent, the popular way of using deep learning is the Google Photos for image recognition. So nowadays, you don't have to put the labels on each images you have taken with the smartphones. Instead, the deep learning algorithms can take any keywords such as beach or boat or cat or flower to find the objects in the smartphone photographs. Gmail applications now has a feature called Smart Reply that shows in option buttons at the bottom of the UI that uses the neural networks to try to understand what's the context of each email thread to show the best replies for each email thread, whether you may want to reply to the email thread as thank you or no thanks or things like that. And it can also detect whether it's a business conversation or conversation with your friends, or it's just a direct mail, commercial, direct mail from some companies, so you can ignore them. Google Translate has introduced the neural machine translation model 2 years ago, and that has increased the fluency of the translated text significantly. So those machine learning can be also very important for the mobile developers and embedded systems developers. Because by using machine learning, it can extract the essence of the data from the raw sensor data. For example, if you are taking any images with smartphones, the easiest way you can do is send all the raw image data to the cloud or server, where you can run some image recognition, the inference or predictions at the server side. But if you can learn the machine learning model inside devices, smartphone or embedded systems, you can use that model to detect the labels from the images, such as the cat or humans or flower. So you can just send the text label to the server instead of sending the whole images. So that could be used as the compression technologies that can compress the data to like 1/100th or the compression ratio could be the 100 times or 200 times. And you can apply the same techniques to any other data, such as the motion detection sensor. Easiest way is to send the raw motion detection sensor data to the server, but you can run this small machine learning model inside the smartphones or devices, Raspberry Pi, to extract so-called embeddings or the feature vectors that can compress the essence of the data into a smaller bytes of data and send them to the cloud. So by using machine learning inside the mobile devices and embedded systems, you can get many benefits like much lower latency because you don't have to check with the cloud, or it can work offline. For example, if you're running the image recognition model inside smartphones, you don't have to have any internet connection at all. You can just use the model inside smartphones to recognize the object. And also, it can access all the data stays in the devices rather than sending all the data to the cloud. And it's power efficient, and all data is accessible by the machine learning model. And we think that the best way to realize implementing the machine learning model inside mobile devices and embedded systems is using TensorFlow. How many people are actually using TensorFlow? Oh, like 20 people, thank you. TensorFlow is an open source framework developed by Google that is actually a standard machine learning framework we have been using at Google for developing any new machine learning or AI-based services. And we have open sourced it in 2015. So anyone can go to the tensorflow.org to download the TensorFlow, the runtime and the framework to your own laptop and get started with it. And the TensorFlow has started as a deep learning framework, but now we are extending the functionality to cover the many other areas of the machine learning. So not only the neural network, we also support the other things like a random forest, SVM, and Gaussian models. And also, TensorFlow is very portable and scalable. So easiest way for you to get started with it is just download the TensorFlow to your own Mac or Windows, so that you can run the smallest sample that recognize the handwritten text. But if you start the more serious examples, then you may find your laptop is not enough to provide the computation power for the deep learning recognition or training. So many people want to use the GPU, which is much faster. If you use the GPU for the training of the deep learning model, usually you would get 10 times or 50 times faster training time. And many enterprises who are really serious about deploying the deep learning into the real-world production systems, they are using a bunch of GPUs, like 10 GPUs or 50 GPUs, or sometimes these few largest enterprises are using the supercomputers, which has hundreds of GPU in a cluster, running TensorFlow in that supercomputer environment to do the so-called distributed training. And once you have trained the model with those GPUs or your Mac or the CPUs, then that model, the neural network itself, that can be ported to any other devices, because usually the deep learning model itself is just a bunch of the numbers with tens of megabytes, less than 100 megabytes. And if you compress it, then you can have the much smaller the models, a few megabytes. So that you can have that model running on inside the smartphones, Android, iOS, or Raspberry Pi, or any embedded Linux systems where you can run the model predictions inside devices, so it's portable. And with those benefits, the TensorFlow has become the world's most popular deep learning framework. We got over 100,000 of the GitHub stars already. And many enterprises are using the TensorFlow for building the POCs or production systems for deep learning. But if you want to bring the technology into the mobile devices or the embedded systems, there are many challenges you have to face. Because with the on-device systems, there's no much memory, main memory, or cache memory, and you have to think about the CPU consumption to save your energy. But neural network is big compared with the other traditional machine learning algorithms. For example, the Inception version 3 model for the image recognition, that takes 91 megabytes as the model or parameters inside it. TensorFlow itself has the really big binary that takes the 12 megabytes. But if you want to have your mobile phone application users using the deep learning algorithms, you don't want to let the users downloading 100 megabytes of the parameters and binaries to their smartphones, smartphone applications. So instead of using the native the raw TensorFlow on devices, you have to apply many different optimization techniques, such as the freezing graph or quantizing the weights and calculations, and selective registration. For example, because you only want to do the prediction or inference on the devices, and you don't want to use the training on the devices, you can remove all the unnecessary part from the TensorFlow models and binaries. One of them is converting the variables to constants, because the training has finished, so you don't have to hold the parameters as variable. Instead, you can convert them into constants. That is much compact and easier to load. And another common technique is quantization. This is a kind of the compression techniques many people are using. For example, in TensorFlow, if you're using any variables to hold the parameters of a neural network model, that usually uses the 32-bit floating point values. But neural network doesn't need that high accuracy or precision for calculating the neural network inference and prediction. So for inference and predictions, you can only have the 8-bit integer to hold a single parameters. And TensorFlow provides the many data types and operations that support that kind of the quantized values. For example, you have the qint8, quantized integer 8-bit, or the operations for the quantizing or dequantizing values, or you can also do the matrix multiplications between the quantized values. And also, by using the technique called selective registration, you can remove the unnecessary binary from the TensorFlow, so that you can reduce the size of the binary from 12 megabytes to 1.5 megabytes. So in the past, you have to learn and apply all of those optimization techniques if you really want to bring the TensorFlow model into the mobile phone or embedded systems. And a few people has been doing that by applying the techniques, but it takes so long time, and it takes much, the learning curve is so high. So the Google is trying to reduce that kind of effort, and we want to make the technology much easier for all the mobile developers. So that is the purpose of the TensorFlow Lite. TensorFlow Lite is another runtime for TensorFlow for mobile and embedded systems that is much easier and faster and smaller than using the original TensorFlow on the mobile devices. And you can start using the TensorFlow Lite with the existing TensorFlow model. So you can continue using the existing TensorFlow the environment framework to train the model. Then you can apply the converter to convert the model to the TensorFlow Lite format. The new format will have the .tf-lite suffix on the file. That will be running on the many different runtimes on Android or iOS or Raspberry Pi. So this is the overall picture of the TensorFlow Lite. So by using the converter, you can convert the original protocol buffer format to the flat buffer format. Flat buffer is a new binary format we are using for the TensorFlow that is optimized for the mobile devices, much smaller and faster deployment with the memory map. And also, we provide the interpreters for the each runtime platforms. And operation kernels have some of the optimized operation executors that is optimized for for example, the Neon, the instructions for the ARM processors. And also the important part is the hardware acceleration delegates that will be accessing the hardware accelerator in each devices. For example, if you are running the TensorFlow Lite on the Android devices, the TensorFlow Lite will be using the Android Neural Network API. And Android NN API is now become a standard API for the Android. That is work as the hardware abstraction layer for the underlying hardware accelerator, such as the DSP, GPU, or CPU. For example, if you are using smartphone with the Qualcomm chipset, the Qualcomm chipset has the DSP, digital signal processor, inside it. That has been traditionally used for the image processing or the audio processing. But you can use the DSP for accelerating the neural network prediction as well, because it's all the product sum operations, the multiplication of the matrix and the vectors. But in the past, you have to go to the Qualcomm website and download the Qualcomm SDK for the C++ and build your own the binary that could be only work on the Qualcomm-based smartphones. So it took so long time to use the DSP or GPU acceleration for your neural network on smartphones, and it's not portable. So instead, by using the Android NN API, the developers don't have to think about each different SDK or APIs for each chipset or devices. And TensorFlow Lite interpreter will be using the Android NN API. So you don't have to even think about the Android NN API. All you have to do is building a TensorFlow Lite model by using the converter. So the interpreter will be converting the models and operations into the NN API. What's the result of this kind of the optimization? For example, this is the graph that compares the TensorFlow, the original TensorFlow, and the TensorFlow Lite quantized format in terms of the inference times. For example, for Inception version 3, it's almost 1/3 of the original inference times. The original Inception version 3 would take like 600 milliseconds for executing a single inference, like recognizing the object in the image. But by using TensorFlow Lite, you can finish the inference in 200 milliseconds. And also the parameters, the models is much smaller by using the quantization. The model size could be 4 times smaller, and inference times could be 3 times faster. And the binary size itself is also very small. As I mentioned, by using the many different techniques such as the selective registration, you still have the 1 megabyte of the TensorFlow binary with the original TensorFlow. But with TensorFlow Lite, the core interpreter only have the 75 kilobytes. And if you have more and more operations you want to use inside the interpreter, that could be up to 400 kilobytes, but still it's very small. And some of you may ask the question such as what's the difference between the MLKit and TensorFlow Lite? And as some of you may know that Firebase has released their own machine learning toolkit called MLKit. What's the difference between the MLKit and the TensorFlow Lite? Actually, the MLKit is designed for the non-machine learning engineers. So if you don't have any experience on writing TensorFlow or using the machine learning at all, maybe easiest way to get started with machine learning is to use MLKit, because it provides the very easy to use the APIs such as the image recognition, image labeling, or OCR, face detection. Smart reply feature is now published as the API, landmark detection, and barcode scanning. So there are many different pre-trained models that Google has developed. So if your requirements fit into those features or functions, then you can just get started with the MLKit. But those APIs on the MLKit features cannot solve all the problems. For example, if you want to recognize some specific images, for example, if you have a Red Bull can, and if you want to create a smartphone application that recognizes your Red Bull can, then you have to train your own machine learning model from scratch that recognizes Red Bull can. So in that kind of the customized use cases, you may want to combine the machine MLKit with TensorFlow Lite, because MLKit allows you to customize your own model by loading the TensorFlow Lite, the model inside it. This is one of the features of the MLKit that allows you to do the real-time face detection. So if you want to use the TensorFlow Lite for your mobile applications, how can you start with the TensorFlow Lite? The easiest way is to go to the documentation of the TensorFlow Lite website. It's under tensorflow.org. So there are a bunch of the documentations and the samples tutorials you can access. So you can go to the demonstrations and the tutorials to learn the basics. And you can start using the Google's pre-trained models and retrained models with TensorFlow Lite. And if you want to build your own model from scratch, you can also build the custom model. And if you want to bring the technology into productions, you may want to apply the optimization before launching the product. So the easiest way to get started with TensorFlow is using the pre-trained model, because there are many different pre-trained models trained for recognizing the general objects, such as, for example, for its image recognition, there are many pre-trained models for object detection and object classification that recognize the usual objects like a flower or cat or human face or things like that. So you don't have to design and train your own model from scratch. Or you can choose to retrain the existing model. For example, if you want to recognize the Red Bull can, then you, rather than training the whole neural network from the scratch, you can retrain the model. So that allows you to shorten the training time much smaller. This is an example video of the use cases of the pre-trained model. So this is how pre-trained model would work. If you recognize the images, then it would show the labels. But if you put any unknown objects like this, the pre-trained model doesn't know anything about this object, so it shows the other labels. So you can retrain the model easily, and you can define a new class like TensorFlow, because it's a TensorFlow logo, and capture some training images like this. And you can start retraining the pre-trained model with new label, and you're seeing that accuracy going up. Because you are not trained the whole model from scratch, it's much faster. So now the model is able to recognize the TensorFlow logo inside the smartphone application. And if you really want to design and train your own models from scratch, there's a way to develop your own model. And first thing you have to do is to use the original TensorFlow and define your model with using APIs such as Estimator or Keras, and get the saved model, and use the converter to convert it. For example, this is the example of converting the saved model. So you save the model for any arbitrary directory and use the converter to get the TensorFlow Lite model. So the converted model will have the .tf-lite suffix. And then you may want to apply any the optimization and the visualization to see how your model will be working. So that by using the visualization model, you can see how each operation is working and how each tensor looks like by using the tensor board, which is the visualization tool. And also, you may want to do the profiling and validating, especially when you are bringing the model into production. And we will be providing more and more performance tuning tool and validation tool for the production usage of the TensorFlow Lite. And we also provide the benchmarking tools and documentation for the best practices. Deploying the model. And we provide the APIs for using the model from the mobile and embedded systems. You can use the APIs for Python, C++, Java, and there are also the experimental APIs for the C and C# and Objective-C. For example, if you are using the Python API in the Raspberry Pi system, then it's really easy to use. First, you have to copy the .tf-lite file into your device and load that model to the interpreter. And you can just call the invoke the function to do the prediction with the model. And like that, the Java API is also very easy to use. Again, you can load the model .tf-lite model into the smartphone device and use the run function, run method, to pass the input data such as the image data or any arbitrary data, and you would get the prediction result. That's so easy. But TensorFlow Lite still have many limitations compared with the original TensorFlow models. For example, it is not supporting all the operations of TensorFlow. We only support up to 75 commonly used operations. So if there's any other operations you want to use inside TensorFlow Lite, you have to use the custom-defined operations by using C#, C++, the API. Okay, so those are the things you have to learn when you want to build your own TensorFlow Lite applications. What kind of application you can create with those technologies? Let's take a look at some of the interesting videos and demonstrations. And Google will be using TensorFlow Lite as a standard tool for building any new mobile and mobile applications for the Android and Google Wear OS. For example, the portrait mode on the Android camera are now using TensorFlow Lite for any AI-related features. And this is actually third-party demonstrations. This is built by some third-party developers that recognize whether the picture is food or non-food. So you can see the score, whether it's a food or non-food. And it's pretty fast, as you can see, and it is only using the CPU of the mobile devices. Another demonstration is called AI in Motion. And this is a demonstration we have shown at the next Google Cloud, the event called Google Cloud Next at San Francisco, Tokyo, and London, where we use those robot balls. It's called Sphero balls. It's like this kind of the round-shaped robot. And usually you have to use the smartphone applications to control that robot, but instead we have used TensorFlow Lite to detect the position of the robot ball and control it. So that you can play some of the games like the freeze tag, human freeze tag, or bot freeze tag between the AI and human. Let's take a look at the video. And as you can see, the TensorFlow Lite model is recognizing the position of each balls on the floor. And it also uses the reinforcement learning to control the ball, to do the tagging with the human player. And there are some other demonstrations that is using the HTPU. HTPU, or TPU, is for the tensor processing units. That is a new AI processor or AI chip designed by Google. And HTPU is a specialized processor for used with the embedded systems that consumes very little power, but provides much, much higher computing power rather than using the ordinary ARM processor or CPU for the Raspberry Pi. And it provides the USB interface. So you can just plug the HTPU with the USB to the Raspberry Pi or any small devices to accelerate the prediction with the prediction with the TensorFlow Lite model. For example, at Cloud Next, we have demonstrated the HTPU, how it can accelerate the face detection. So this is the video. So as you can see, the HTPU running TensorFlow Lite model can detect the bounding box of each face, and also it even detects the 3D heading direction of each head, running at the almost 60 FPS. There's another demonstration called Smart Shopping Navigator. This is another demonstration that puts the Raspberry Pi on a shopping cart with the webcam to detect what kind of items, like vegetables or food items inside shopping cart, to show the recommended recipes for foods. Oh, I didn't set the autoplay. So this is an Intel Nuke box. So it's a usual PC, and we have plugged the HTPU with USB. So if you put any food items like vegetables, potatoes, then HTPU and TensorFlow Lite model can recognize the object at about, I can see, so it's less than 2 milliseconds, 1.5 milliseconds. If you do this with the cloud-based API, then it would take like 1 second or maybe 500 milliseconds. So it's like 100 times faster than using the cloud APIs. It's almost real time. Okay, let me. Another interesting application is called call screen. This is for the screen incoming calls. So some spammers or maybe marketers will be calling to your smartphones, and you don't want to take that call. So we are trying to use the Google Duplex technologies to interact with those spam callers. So let's take a look at.
So I'm going to tap on the call screen.
Hi, the person you're calling is using a screening service from Google and will get a copy of this conversation. Go ahead and say your name and why you're calling.
Hi, I'd love to talk to you about some amazing deals we have for you today.
I don't know. Is that right or not? Is he a sketchy spammer? Tell me more.
Just so it's clear, go ahead and say more about why you're calling.
You've actually won a free cruise. All I need is your credit card and your social security number.
I'm thinking maybe not.
So usually this kind of the very high quality voice recognition and voice synthesizer takes the much computation power. Usually you may want to use the cloud resource to do that, but this demonstration was all done with the TensorFlow Lite model running inside smartphones. That's the power of the TensorFlow Lite and benefit you can get with the model. And lastly, I'd like to show the very interesting, fun example that is Gymnastic exercise scorer. And I have to explain what it's all about. This is a Japanese application. And there's a very popular exercise called radio exercise in Japan, because the National Radio Broadcasting Network in Japan, called NHK, they place the same gymnastic exercise music at around 6 a.m. or 6:30 a.m. every morning. And so the millions of the Japanese people doing the same exercise, listening to that music. So that is called radio exercise. And this application is a scorer for that applications. And this has been on production for over 2 years by using the TensorFlow. And this is not using TensorFlow Lite because 2 years ago there was no TensorFlow Lite, but they have built their own TensorFlow compiler to apply the optimization technique I have described, such as the quantization or removing the training part or any other the optimization technique, so that they were able to compress the original tens of megabytes. I think it's over 50 megabytes or maybe 70 megabytes of the data compressed into 2 or 3 megabytes, so that they were able to embed that TensorFlow model into a small production smartphone application that detects the motion of the exercise. So let's take a look at the demonstration. So let's take a look at the live demonstration of the exercise scorer. So can I switch to the So this is the applications where you can choose the various kinds of the exercises. So now the TensorFlow model is trying to evaluate how well you have done with the exercise. And you can see the bar chart here. That is the evaluation by the TensorFlow model inside these applications. It's a real thing. So this is the bar chart. And this is scored by the TensorFlow model. Not TensorFlow Lite, because at that time there was no TensorFlow Lite. So by using TensorFlow Lite, it's much, much easier for the developers to build the application like this. Okay. So if you are interested in the technology, please go to the GitHub repository for the TensorFlow Lite, or go to the documentations and learn about the technologies. That's it. Thank you.